Hello everyone, let's talk about quicksort. Quicksort follows divide and conquer pattern. Before move on to actual algorithm, let's see the analogy of quicksort. Assume you have an array of length 4. We consider mid-index value as pivot. We move all the elements less than or equal to pivot to the left side and all the elements which are greater than pivot to the right side. So that with respect to pivot, the array will be sorted. And we apply the same strategy to the left part and the right part recursively. That's it. That's how the quicksort works. Let me walk through the algorithm. Assume you have an element of size 8 and obviously the pivot value is going to be mid-index value which is 2. We are going to partition this array where all the elements less than or equal to 2 move on to the left side, greater than 2 will move on to right. So left pointer points to 0th index, right pointer points to index 7. Then see here the left value is greater than pivot. So we move the right pointer where the value is less than pivot. So here 1 is less than pivot 2. So that it's time to swap element 5 and element 1. Then we move the left and right pointer. Again move the left pointer where the value is greater than pivot. See here 8 is greater than pivot 2 and right value 2 which is equal to pivot. So it's time to swap these two elements, then increment the left, decrement the right pointer. Now our left pointer is greater than right pointer. It means we are done with partitioning the array with respect to pivot 2. See here all the values to the left less than or equal to pivot 2, all the values to the right greater than pivot 2. Then we apply the quicksort to the left part of the pivot to the right part of the pivot recursively. Let's move on to left part. You have a pivot value as 1. So that left pointer points to index 0, right pointer points to index 1. Right value is greater than pivot, so we just decrement the right pointer. So with this, there are no elements to compare. So we are done with sorting with respect to pivot 1. So we move on to right part. We left with only one element 2, which is already sorted. So we are done with sorting left part of the pivot 2. Let's move on to right part of the pivot 2. So here the pivot value is going to be 6. So then left pointer is going to be index 3, right pointer is going to be index 7. See here my left value 8 which is greater than pivot 6, right value 3 which is less than pivot 6. So we just swap it. Then move the left and right pointer. So now our left value is 5 which is less than 6. It means it is in right position. So we increment the left pointer, right value 7 which is greater than pivot. So we just decrement the right pointer. With this we are done with partitioning the values with respect to pivot 6. So all the elements to the left less than 6, all the elements to the right greater than 6. Now let's apply the same technique to the left part of the pivot 6, similarly to the right part of the pivot 6. That's it. So that's how the quicksort works. So very simple. So you take a mid index, the mid index value is going to be the pivot, then we just swap based on pivot. That's it. So let me understanding time complexity of a quicksort is little complex. So let me walk through this analogy. See here you have an array of length 8. So we are going to consider a pivot. So which is going to divide this array into two parts, n by 2 and n by 2. At left side, approximately you will have n by 2 elements which are less than or equal to pivot. Right side, approximately you have n by 2 elements which are greater than pivot. So approximately it takes n comparisons. Let's move on to the level 2. Again, you will have two pivots and each pivot divides into n by 4 and n by 4. Again, approximately you have n comparisons. Then finally you have level 3 where you will have 4 pivots. So it approximately divides into n by 8 and n by 8. So at level 3 also you have approximately n comparisons. See here we have total 8 elements. It took 3 levels to sort the array. So log 8 base 2 is equal to 3. And at each level we have n comparisons approximately, so that on an average case the time complexity will be n log n, and space complexity is constant because we are using in place algorithm. Let's talk about the stability. When you have a duplicate keys, after applying quicksort, is it preserving the order or not? See here we have a duplicate key with the blue one and red one, but red one came after blue one. So after applying quicksort, is it preserving the order or not? Let's see that. See here, after applying quicksort, the red one came before the blue one, so that it's not preserving the order. So the stability of a quicksort is unstable. And quicksort is meant for internal sorting and it's a recursive solution. So before submitting the code, so let me walk through the code. So the most important logic is partitioning the array, where you will get input array, left index and right index. Mid index is going to be average of these two, then pivot value is going to be mid index value. We move on until left index less than or equal to right index. Whenever left value less than pivot, we just increment the left index. Whenever right value greater than pivot, we just decrement the right index. When left index less than or equal to right index, it means our left value is greater than pivot, right value is less than pivot, so that we just apply a swap. That's it. Once we are done with, we are returning the left index as a new pivot index. So initially you will be having a sort array method. It takes input array, which internally initiate a quicksort call by passing input array index 0 and n minus 1. Then the quicksort takes up the given data and it will initiate a partition logic by passing given input array and left index and right index. Then and then the partition method will apply the partitioning based on the pivot and return the new pivot index. If the left index less than pivot index minus 1, it means we apply a quicksort to the left part of the pivot. If right index is greater than pivot index, then we apply a quicksort to the right part of the pivot, where the start index going to be pivot index, end index going to be right index. That's it. That the most critical part is partitioning the array based on the left and right index. That's it. So you can find the complete code on my GitHub. Link is available in the description. Let me go and submit the code, which I walked through earlier. So let me submit. That's it. So hope you like the explanation. Thanks for watching. My name is Srinu. I see you next time.